The normal distribution. The normal distribution is an example of a continuous random variable. It has a probability density function given by f of x is 1 over sigma root 2 pi e to the negative a half x minus mu over sigma, all squared. And in this formula, sigma is the standard deviation and mu is the mean. The shape of the distribution is described as bell-shaped, but the shape of the bell varies as the value of sigma changes. So I've got a variety of them here. The red one has a high standard deviation. The green one has the smallest standard deviation here. The peak corresponds to the position of the mean, so the means are different for each of these distributions. The probability that the function takes a value between two values is given by the area under the curve. So if we're interested in the probability of x being between a and b, we're talking about this area here. The function, however, this function here, is very difficult to integrate. So these areas are usually calculated using a calculator, and in times past, we used to use tables of values. Note, for a continuous random variable, the probability that it takes any one value is 0. So the probability of x being between a and b is equal to the probability that x is greater than or equal to a and less than or equal to b, because the probability of it actually being a or b is 0. There are some features we should note about the normal distribution. The distribution is perfectly symmetrical about the mean. The mean is equal to the median is equal to the mode. There is a point of inflection, one standard deviation from the mean. Approximately 68% of values lie within one standard deviation from the mean. It's approximately 95.4% for 2 standard deviations and 99.7% for 3 standard deviations. So if we look at this distribution here, where the mean is here, that's minus 1 standard deviation, and that's plus 1. Then we get the oblique point of inflection just here. 68.4% of the data would be represented by this area between -1 and +1 standard deviations from the mean. There is a special normal distribution known as the standard normal distribution, which used to be a lot more important in the days when we used to have tables, because tables would be for the standard normal. The standard normal is a normal distribution with a mean of 0 and a standard deviation of 1. It's usually given the special letter z, so z follows a normal distribution, and the parameters here are the mean and the variance, not the standard deviation. But in the case of the standard normal, 1 squared is 1. The parameters of a normal distribution, as I just said, are the mean and the variance. A general normal, therefore, follows a normal distribution with a mean of mu and a variance of sigma squared, where sigma is the standard deviation.